Okay. Hello, my name is Delcia. I'm going to talk about polarization and intermolecular forces. Polar covalent bonds connect two atoms with different electron activities, leaving one atom with a partial positive charge and the other atom with a partial negative charge, as the electrons are pulled towards the more electronegative atom. For example, hydrogen and bromine. Bromine has a strong electronegativity and is negative charge, and electrons are attracted towards itself, and hydrogen become positive charge, less positive charge. Dipole moment. Dipole moment is a measure of polarity of a molecule where there is a difference in electronegativities between two or more atoms. The bond dipole moment is a vector quantity since it has both magnitude and direction. My example here is hydrogen chloride. Dipole moment is represented by the Greek letter mu and is given by the formula shown below, where Q is the magnitude of the partial charges, which is determined by the electronegativity differences, and R is the distance between the charges. The formula is U equals to QR. To determine whether a molecule with more than two atoms is polar, the following things have to be taken into consideration: the polarity of each bond and how the bonds are arranged in the molecule. Some molecules have polar bond but are overall not polar because the polar bond in the molecule are arranged in such a way that the individual dipole moments cancel each other out. Dipole vectors shows arrows pointing along the bond from the less electronegative atom towards the more electronegative atom. A small plus sign is drawn on the less electronegative atom end to indicate the partiality positive end of their bond. The length of the arrow is proportional to the magnitude of the electronegative difference between the two atoms, as my example states there. The intermolecular force. The type of intermolecular bond in covalent substances are hydrogen bonds, dipole-dipole attractions, dipole-induced dipole attractions, and London depression forces. Water has a polar of oxygen and hydrogen bonds. The negative oxygen atom attracts the positive hydrogen atom in nearby molecules, leading to the unusually strong type of dipole-dipole force called a hydrogen bond. Water also has a dipole-induced dipole and the London depression forces. Hydrogen bonds are the strongest force, but there is other type of intermolecular attractions that are still present. The consequences of multiple hydrogen bonding in water. Hydrogen bonding makes ice less dense than liquid water, so ice floats on water. The effect of hydrogen bonding on heat of evaporation helps make perspiration an effective means of lowering temperature for animals. The effect on heat capacity means water protects against extreme temperature shift near large bodies of water or humid environments. Water helps regulate temperature on a global scale. It is also an excellent solvent. It is capable of dissolving more substances than any other liquid. Thank you for watching.